As we know that we received on Earth shortwave incoming solar radiation from the sun. So how does that radiation come? So in the sun we have a thermonuclear reaction inside happening all the time. So core of the sun is all about 15 million degrees centigrade. The surface is little cooler, but still in terms of the hotness it is a very hot furnace, is about 10,000 degrees Celsius. So sun is very hot and hot object, according to physics 101, that hot object emit shortwave radiation. So sun is a very intense hot and enough to radiate shortwave radiation, and including ultraviolet radiation, visible spectrum, infrared, terrestrial radiation, and everything sun is emitting. The sun has a core, radiative zone, interface layer, and convective zone. This is all process that we get some solar radiation. Now in this slide, what is happening? Sun, as it is hot, it is actually releasing a shortwave radiation over here. So this is the shortwave radiation because sun is hot object. When this shortwave radiation absorbed by the earth itself is not that much intense hot, so it is actually releasing long wave radiation. So that's called terrestrial radiation. This is how our earth process to release long wave terrestrial radiation. So as we know that electromagnetic radiation can be classified on the basis of the wavelength, the distance between the crest of one wave and the crest of the next wave. We call it wavelength. Collectively, electromagnetic radiation of all wavelength comprise what is called electromagnetic spectrum. So electromagnetic radiation varies enormously in the wavelength ranging from the exceedingly short wavelength of gamma ray and X-ray, with some of the wavelength less than 1 billionth of a meter, and this exceedingly we have long wave length of television wave, radio wave, with some wavelength measured in the kilometers. That's long wavelength. So in the visible light, if we are talking about the wavelength of the radiation to which the human eye is sensible or sensitive to make up a fairly narrow band of the electromagnetic spectrum, we call it visible light. And this visible light, the wavelength is actually include 0.4 to 0.7 micrometer. So 1 micrometer is equal to 1 millionth of a meter. So it's very tiny. So visible light range from shortest wavelength of radiation of human eye can sense or see. So it violet through the progressively longer wavelength of blue, green, yellow, orange, and finally the red. So the longest wavelength of the radiation of human eye can see, this sequence of color is same as you see in the rainbow. So from the inner to outer when we see the rainbow. So there is other types of, and this portion of the electromagnetic radiation that's coming from the sun, visible light, is about 47% of the total light, so give or take. So ultraviolet radiation is another short wave radiation that we receive from the sun. So wavelength of this radiation just shorter than the human eye can sense. So with the wavelength from about 0.01 to 0.04 millimicron makes up ultraviolet portion of the electromagnetic spectrum. The sun gives us these types of electromagnetic radiation, and we know that in the second layer of the atmosphere we have ozone layer. So most of the ultraviolet radiation absorbed by the ozone layer. So we have another infrared radiation that is longer than the visible light and also ultraviolet radiation, and this is wavelengths that radiation just longer than the human eye can sense make up to infrared portion of the electromagnetic radiation, with the wavelength between 0.7 and about 1000 micrometer. So infrared radiation range a short or near infrared wavelength emitted by the sun to much longer wavelength, sometimes called thermal infrared. That so if we would like to differ the short wave versus the long wave radiation, solar radiation is almost completely in the form of visible light, ultraviolet and short infrared radiation, which as a group we call it short wave radiation. So radiation emitted by Earth or terrestrial radiation is entirely in the thermal infrared portion of the spectrum, and it is referred to a long wave radiation. So a wavelength about 4 micrometer is considered the boundary of the spectrum separating the long wave radiation from the short wave radiation. So all terrestrial radiation is long wave radiation, and all virtually all solar radiation is short wave radiation. So on our earth, when we have the energy budget, so almost we consider all the wavelengths that's coming from sun for the hot furnace is short wave radiation, and the amount of terrestrial infrared radiation emitted by the earth is considered as a long wave radiation.